Welcome. In this lesson, we're going to talk about how to interpret the graphs of proportional relationships. We've already seen how to make tables and equations for them, and we know what a graph of a proportional relationship looks like. Now we're going to look at the points specifically on that graph. Let's take a look at example 1 from lesson 10. In this example, Grandma's special chocolate chip cookie recipe, which yields, that means it makes, 4 dozen cookies, calls for 3 cups of flour. So for every 3 cups of flour we use, we get 4 dozen cookies. We're going to use this information to complete the chart. Now the chart in your book has 6 boxes. I'm showing the first 3 here. We'll see the next 3 on the next slide. First, we want to create a table comparing the amount of flour used to the amount of cookies. In my table, I have cups of flour and dozens of cookies as my title. The cups of flour is the independent variable because how many dozens of cookies depends on how many cups of flour we have. So cups of flour would be our X and dozens of cookies would be our Y. The first entry on our table, we can put the relationship given in our original sentence. 3 cups of flour gives us 4 dozen cookies. We can fill out the rest of the table by multiplying both parts of this ratio by the same value. If I multiply both 3 and 4 by 2, I get 6 cups of flour will give me 8 dozen cookies. If I multiply both 3 and 4 by 3, I get 9 cups of flour and 12 dozen cookies. And then if I multiply both 3 and 4 by 4, I get 12 cups of flour, gives me 16 dozen cookies. So here is a table that shows the relationship between the cups of flour and the dozens of cookies. It is a table of equivalent ratios. The second part of our grid asks us, is the number of cookies proportional to the amount of flour used? And to explain why or why not. We know that these values are proportional because the value is the same for each ratio, 1 and 1/3. If we do 4 divided by 3, y divided by x, we get the same thing each time. 8 divided by 6 is the same as 12 divided by 9, which is the same as 16 divided by 12. They all equal 1 and 1/3, or 1.3 repeating. The third box asks what is the unit rate of the cookies to flour. So dozens of cookies, y, to cups of flour, x. And what is the meaning in the context of the problem? That's really important. In this problem, what does the number we get mean? Well, the unit rate is 1 and 1/3 dozens per cup. It means that for every 1 cup of flour, you can make 1 and 1/3 dozen cookies. Now I wrote it as a fraction here, 1 and 1/3. I wrote it as a decimal here, 1 and 1/3, or 1 and 3/10 repeating. You could also write it as an improper fraction, like 4/3. Let's take a look at the next 3 boxes. In the third box, we want to model the relationship on a graph. First, we need to label our graph. We need to label the x-axis and the y-axis. The x-axis is cups of flour, and I numbered mine by 5s, but every line still equals 1. On my y-axis, I have dozens of cookies, and again, I labeled them by 5s, but each mark still equals 1 here. Now we need to place our points on the graph. First, I'm going to put the point 3, 4. 3 cups of flour gives me 4 dozen cookies. Now I'm going to put the rest of the points on there. 6, 8, 9, 12, and 12, 16. The second part of this asks, does the graph show the 2 quantities being proportional to each other, and explain? Well, here we have the points on the graph, and if I draw a line through them, I can see that this line goes through the origin, and the line is straight. So yes, the graph shows the 2 quantities are proportional. The points on the graph are in a straight line, and that line goes through the origin, 0, 0. Our last part of our grid asks us to write an equation that can be used to represent the relationship. Remember, we're going to use the equation y equals k, our constant proportionality, times x. In this example, our x is cups of flour, so we're going to use an F. And our y is cookies in dozens, so we're going to use a C. So we're going to have C equals our constant of proportionality times F. In this case, our constant of proportionality is the same as our unit rate. So we're going to write the equation D for the dozens of cookies, not C, equals 1 1/3 times F, or D equals 1.3 repeating times F. So this would be the equation we would write. We used our unit of rate, or our constant proportionality, they're the same thing, in the equation. Let's take a look at example 2 and see a little bit more about graphs. In example 2, we already have the graph drawn, and it models the amount of sugar required to make Grandma's special chocolate chip cookies. So we're comparing the cups of sugar on our x-axis to the dozens of cookies on our y-axis. The number of cookies we make depends on how many cups of sugar we have. So our cups of sugar are our independent variable. We're going to record the coordinates from the graph and say what do the ordered pairs represent in this particular example. So each one of these dots is an ordered pair. There's lots of other ordered pairs on here, but we're just going to record the ones that they have pointed out. Our first ordered pair is 0, 0. It means 0 cups of sugar can be used to make 0 cookies. Our next point is 2, 3. 2 cups of sugar can be used to make 3 dozen cookies. And here's the point, 4, 6. 4 cups of sugar can be used to make 6 dozen cookies. A little further up, we have 8 cups of sugar can be used to make 12 dozen cookies. This is the point 8, 12. We also have the point 12, 18. 12 cups of sugar can be used to make 18 dozen cookies. And our last point on the graph, 16, 24. 16 cups of sugar can be used to make 24 dozen cookies. So if we knew we wanted to make 3 dozen cookies, or 6 dozen cookies, or 12 dozen cookies, or 18 dozen cookies, or 24 dozen cookies, we could look at these points and know how many cups of sugar we needed. But this line shows tons of other points. There's the point 6 cups of sugar gives us 9 dozen cookies. We even have points in between. It looks like if we had a little bit more than 4 cups of sugar, maybe 4 1/3 cups of sugar, we could make 5 dozen cookies. Every place this line is a point that represents this relationship. Let's look at a specific one. Grandma has 1 remaining cup of sugar. We want to know how many dozen cookies she will be able to make. Well, if she has 1 remaining cup of sugar, here's 1 cup of sugar. If we follow this up to the line, looks like the line crosses right here at 1 1/2. So at 1 cup of sugar, the graph crosses at 1 1/2 dozen cookies. She will be able to make 1 1/2 dozen cookies if she has 1 cup of sugar. There's the point. It's kind of big the way I drew it. 1.5 is also the constant of proportionality. If we took 3 and divided it by 2, we would get 1.5. 4 divided by 6, we would get 1.5. 12 divided by 8, and so on. Our last question is how many dozen cookies can Grandma make if she has no sugar? If she has 0 cups of sugar? If Grandma does not have any sugar, she cannot make any cookies. This is the point 0, 0. It's called the origin, and it's already plotted on the coordinate plane right here. It was the first point we talked about. All right, there are 2 examples for tonight's homework. Make sure you fill out your workbook. If you want, you can even take a look at the problems that come after this in the exercises. We'll talk about it in class. See you then.